Are you ready to be a part of the solution for a greener planet? With the power of machine learning and artificial intelligence, we are revolutionizing the way we consume energy and resources. This presentation will show how cutting-edge technology helps to optimize energy consumption, significantly reducing our carbon footprint. It's more than just an industrial application. It's our commitment to the planet. Join us in our journey towards achieving the targets of Paris Agreement, aiming climate-neutral economy and society by 2050. In this presentation, we will cover the following topics. Why do we need to optimize consumption? It's not just a necessity, but has a crucial importance for sustainable development. We will explore how we can make energy production more efficient. We will take the example of district heating and demonstrate how we can optimize this process, reduce waste and improve efficiency by using intelligent control strategies. We will also look at the other side of the coin, consumption. How can we make sure that the energy we produce is used efficiently? Finally, we will discuss demand-side management, a strategy to adjust consumer demand for energy through intelligent strategies. It is always important to consider the problem of energy optimization from two angles, from the point of view of energy production and from energy consumption point of view. The amount of renewable energy, solar panels, wind turbines, etc., is constantly growing, and this requires utilization of AI-based algorithms. AI-based methods can be used to model complex processes, understand some important phenomena, predict behavior of the systems, and make smart decisions. The primary intelligent approach for optimizing both consumption and production is through intelligent control, which can be represented using the scheme illustrated on this slide. If classical reactive control reacts to the situation and adjusts production, then intelligent proactive control predicts the demand and uses the exact amount of energy. Proactive control technique utilizes AI to predict dynamic features and make control actions in advance, taking into account the dynamics and inertia of the process. In this example, gas is used as a source of energy, resource, and output is water or steam at the required temperature. Consumption changes over time, and as the result, the amount of the required gas changes. Here comes the optimization point. To minimize the consumption of resources, we need to have short-term predictions of the situation, a dynamic process, for at least the next 5-10 minutes. This allows us to react proactively and reduce energy waste. As the result, control becomes more accurate, fluctuations of temperature smaller, and resources are not wasted. This diagram demonstrates energy consumption by sectors. So you can see that buildings are the primary energy consumers in Europe, accounting for approximately 40% of total energy consumption. It can be seen that the technical systems in commercial buildings consume about 7.5% of the total energy in Europe. Implementing intelligent algorithms in these systems can lead to significant reduction in consumption and have a substantial impact. Reducing consumption by 30% in heating, ventilation, and air conditioning systems, for example, would result in an approximately 2.5% reduction of European energy consumption and CO2 emissions. That represents a significant and positive impact. These results can be achieved using a so-called demand-side management, or DSM. Classical automation systems lack predictive capabilities and the ability to consider all relevant factors. To name some of them, indoor temperatures, CO2 levels, outdoor temperature trends, forecasts, occupancy level, technical conditions, electricity price, and many others. An average commercial building typically may have around 50,000 measurement points and approximately 3,000 points out of them are controllable, meaning that they can be adjusted to directly influence energy consumption. For a human being, the task is getting too complex and almost impossible. This is where AI comes into play, helping to handle and analyze all this data, make necessary adjustments, maintain a high level of indoor climate and air quality, and reduce energy consumption. When these adjustments are made in real time, we can call it demand-side management. At the end of each unit, you will find several questions to test your knowledge. Here is one of the questions. What is the aim of the Paris Agreement? The answer lies within the materials covered in this unit.